Sanibonani, Dumelani, Abushini, Moren. Greetings to you all. Today we will be doing the arithmetic series. So let us start.
Now guys, an arithmetic series, a series is formed by adding the terms of what? The terms of a sequence. Now let us say this is a sequence. T1 is to T2, T3, and term number 4, etc. So now this one will represent what? Will represent a sequence. Then the sum of this sequence, that will be T1 plus T2 plus T3, T4 plus T5, etc. So when adding the terms of a sequence, that will be what? That will be called a series. Now, we also have a finite series is when only the first n number of terms of the sequence are added. And we also have an infinite series is when we use all the terms of the sequence. So this one will be discussed later during the lessons. Okay. Now let us do the examples. Now we've got this sequence. This one is the sequence. Let's say maybe it's 1 is to 4 is to 7 is to 10 is to 13. Okay. So what will be the series for this sequence? That will be 1 plus 4 plus 7 plus 10 plus 13. That will be what? That will be a series for this sequence. Example 2, let's say we've got 5 is to 2 is to negative 1 is to negative 4. Now this will be what? This will be a sequence. Now the series of this sequence, we have to add the terms of this, what to call, sequence. That will be 5 plus 2 plus negative 1 plus negative 4 plus the etc going forward. Now you understand the series of a sequence. Now let us move to the next thing, which is the sum of the arithmetic sequence formula. Okay, so now the formula allows you to determine what the sum of the first n terms of an arithmetic sequence. Now the formula is like this. It's Sn is equals to n over 2, 2a plus 1 plus n into negative 1, all into multiplied by d. Okay, plus open bracket n minus 1 times d. Okay. Now, where a is the first term, d is the constant difference, because we are working with the arithmetic sequence, and number of what is the number of terms. Okay. Now let us go to the next one, which is Sn, which now becomes the sum of the first n terms. The sum of the first n terms. Okay, let us also discuss the second, what to call, formula for what? For determining the sum of the first n terms. That will be Sn is equals to n over 2 into bracket a plus l, all close bracket, where a is the first term, l is the sorry for that, l is the last term, l is the last term, l is the last term. Okay. Now this is the number of terms. Okay, this should be the number of terms. This should be the number of terms. Okay, the number of terms. This one as well should be the number of what? The number of terms, okay? The number of terms, okay? The number of terms, good. Now, this one is the last term, L for last term, N for the number of what? The number of terms. Sn is equal to the sum of the first n terms. Okay. Now let us do example 1, finding the sum. Now find the sum of the first 20 terms of the series. That will be -1 plus 3 plus 7. Okay, so we know that A, which is what? Which is the first term. We now have what? We now have A. Okay, A, which is equal to -1. Okay, so we have to find what? The difference. The difference is going to be T2 minus T1. Okay, now the difference is going to be equal to 3 minus into -1. This is going to give us +4. So the difference is equal to 4. Is equal to 4. Now we are asked to find the sum of the first 20 terms. We've got what? We've got n is equal to what? N is equal to 20. N is equal to 20. Okay, which is the number of terms. So we are asked to find the first 20 terms. So we use our formula here. As you can see here, we don't have the last term. Okay, this series continues like that, but we do not know what is the last term, so we cannot use this formula because we don't know what is the last term. So we're gonna be using this one. So we're gonna have Sn is equal to n over 2 into 2a plus n minus 1 d, and close bracket. So we're asked to find the sum of 20 terms. So that will be S20 is equal to 20 over 2 into A is what? A is -1 plus into n is what? N is 20. Okay, that will be 20 minus 1. Okay, now what is the constant difference? The difference is equal to 4. We put 4 there and we close the bracket, and now we can punch all this in our calculator. That will be what? That will be 20 over 2 into 2 into A is -1 plus 20 minus 1, 4, close our bracket, and I got 740. So the sum of the first 20 terms of this series is going to be equal to 740. Okay, yes, this is how we use the arithmetic, the sum of the arithmetic sequence formula. Now let us do example 2. Okay, finding the sum when the number of terms is not known at first. Okay, because for us to find sum, we need to have the number of what? The number of terms, n. We need to find n, which is the number of terms. Okay, now we have this series. 3, 5, 7, plus a couple of other terms, and the last term here is what? Is 111. Okay, so we are going to use two ways to solve the sum to answer B. But let us start with A. We have to start with A. How many terms are there in a series? In a series. Now this is how we're gonna do this one. What do we have? We have the first term, which is A. So we know that A is equal to what? Is equal to 3. Okay, and we also know this is arithmetic. We are also going to have a constant difference. The constant difference that will be D is equal to T2 minus T1. Okay, so that will be equal to 5 minus 3. That will be what? That will be equal to 2. So this is going to be our constant difference. Okay, that will be our constant difference. But now we know what is the last term, but we do not know what to call the number of terms. Okay, so we have to find the number of terms. Now we are not going to be using the sum of the arithmetic sequence formula, but we are going to use the general term formula. So how do we use the general term formula? That will be Tn is equal to A plus n minus 1 D. Okay, D. So our last term is this one. So we can simply substitute this one here. This is going to be 111 is equal to, we know what A is is equal to 3. We substitute 3 then, plus into, we do not know the number of terms, term number, that will be n minus 1 into, we've got what? We've got the constant difference, which is equal to 2. That will be 2. Okay, and then we find what? We find n. Okay, so we're gonna say when we transpose this one, this is going to be 111 minus 3, okay, is equal to, working out this one is going to be 2n minus 2. Okay, and then we also transpose this one to the other side of the equation. That will be 111 minus 3 plus 2 is equal to 2n. Okay, so how much are we going to get there? We're going to have 110 is equal to 2n. We got 2n. Okay, we need to find n. What do? We divide both sides by 2. This takes 2 out. Now we've got what? That will be divided by 2. That will be 55. N is equal to 55. N is equal to 55. So it means this is term number 55, the 55th term, this one. Okay, so we've got 55 terms in this series. We know that we've got 55 terms in this series. Okay, now this was A. This was A. Now we go to the next question. Okay, let us just, there are 55 terms, let us say, in this series. There are 55 terms in this series. Now let us do B. What is the sum of the series? Okay. What is the sum of the series? So we are going to do this one in two ways. So for B, what do we have? We have A, okay? A, which is equal to 3. We also have D, which is equal to 2, and we also know N. We also know N, which is equal to 55. So we need to know the sum of all the terms in this series. So we're gonna use this one. The first one will be Sn is equal to n over 2 into 2a plus n minus 1 d. N minus 1 d. Those brackets. So we need to find the sum of the first 55 terms. The number of terms, that will be 55 divided by 2 into 2. What is A? A is 3 plus, that will be 55 minus 1. What is the constant difference? The constant difference is 2. Close bracket. And we punch all these in our calculator. We're gonna have 55 divided by 2 into 2 times 3 plus 55 minus 1 times 2. That will be what? That will be 3,135. That will be the sum of what? That will be the sum of the 55 terms. Okay, good. Now another way of doing it, because we've got two formulas, I used this one. Okay, we can also use this one because we know what is the last term. We know what is the last term. The last term here is what? Is 111. So let us use the alternative method. Is we know what? We know A. We know A is equal to 3 and L is equal to 111. Okay, so we say Sn is equal to n over 2 A plus L. Okay, so now we want the sum of the first 55 terms. So this is going to be equal to 55 over 2 into A is equal to 3 plus the last term is what? 111. And then we punch all these in our calculator. That's a 55 divided by 2 times 3 plus 111, and we also get what? 3,135. 3,135, which is the same as that. Okay, now let us go to example 3. Let us do example 3. Now, finding, we now want to find the term number n when the sum is known. To us. Okay. Now, consider the arithmetic sequence 4, 7, 10, 13, 16 will add up to 175. So this 175 is not the last term, will add up to this. So this is going to be our Sn. This is going to be our Sn. It's not the last term. In the previous example, we had the last term there, but here this is the sum. They will add up to this. Okay. Now we need to find what? We need to find the number of terms. Okay. So we come here. What do we have? Okay. We have a, which is equal to 4. Okay. So we need to find what? From here we need to find the constant difference. So that will be d is equal to t2 minus t1. That will be 7 minus 4. We get 3 as our constant difference. So we have what? We've got Sn, but we need to find what? We need to find n. We need to find n. So we use our formula for calculating sum. That will be Sn is equal to n over 2 2a plus n minus 1 d. Okay. So we know that the sum of what? The sum of the terms that will add up to they will add up to 175. So we have to substitute Sn as what? As 175. Okay, so we don't know what we're looking for. We're looking for n. That will be n divided by 2. 2 into a is equal to 4, plus we are also looking for what? We are also looking for n minus 1, and we have the constant difference, which is 3. We close our bracket like that. So what are we going to have? We're going to have 175 equal to n over 2 into this is going to be 8 plus, when we make this one, that will be 3n minus 3. Okay, so what do we have? We're gonna have 175 and 175, which is equal to what do we have here? N over 2. 8 minus 3, that will be 5 plus 3n. Okay, and then we work this one out. We still have 170. We still have 175, which is equal to that will be 5 over 2 n. When we multiply the 2 and then we multiply this, that will be plus this times that, that will be 3 over 2n squared. Okay, so when we write this in standard form, we're going to transpose this one to the other side. That will be so we're gonna have 0, which is equal to what? 3 over 2 n squared, plus, because it's positive 5 over 2 n, minus, because we're transposing this to this side, that will be minus 175. Okay, so since we have our our unknown like this, we can use what? We can use the quadratic equation. With our quadratic equation, n is equals to, we're going to say n is equals to, that will be n is equal to, that will be negative b plus or minus the square root of b squared minus 4ac over 2a. Yes, should be like this. This is the quadratic equation. Okay, so when we substitute our b will be the coefficient of the second term there. That will be what? 5 over 2. That will be negative 5 over 2. That will be negative 5 over 2 plus or minus the square root of 5 over 2, the square root of 5 over 2 squared minus 4a is 3 over 2. Okay, c is negative minus 175. Okay, all over 2 into, what is it? What is b? 2a, which is 2a is 3 over 2. Okay, so you're gonna have two answers, two solutions for this, or n is equal to, we're gonna have two solutions for this. So that will be what? Gonna start with the positive sign here. That will be negative 5 over 2 plus the square root of 5 over 2 squared minus 4a 3 over 2 negative 175. Negative 175 over all over 2a. A is 3 over 2 close bracket. We're gonna have n is equal to 10. And now we have to use the negative sign there. So I'm just going to delete the positive sign here and use negative. So what do we have? We have negative 35 over 3. Okay, so and the correct one is going to be equal to n is equal to 10 is the correct one. Okay, and this one is not, this one is not valid. Okay, this one simply because n must be what? N must be a natural number. N must be a natural number. Okay, so that will be the end of my lesson. So I will also come again and do the arithmetic series and sigma notation on our next lesson. So thank you.